Hello and welcome to a new video. My name is Herwig Juster and today we discuss in the second part of our electrical design properties for electric cars the flammability ratings. Okay, let us get started. First, the concept of the holistic approach in polymer material selection. So here it is important to have a good understanding of the application design requirements on the one hand, and on the other hand on the material properties. This is enabling an optimal material selection. There are different processes in material selection, and for example here I've shown the polymer selection funnel which I have created and consists out of 4 steps, where we start with the material selection factors, then decide on thermoplastic or thermoset resin, and then there is a detailed selection discussion with worksheets, and in the 4th step the testing selection of the material and the vendor. And today we continue our journey of relevant electrical properties for applications in the mobility field, and in the end we will also of this series will discuss then application requirements and examples. So when you think of plastic compounds for e-mobility application, it has to fulfill several requirements, and so they range from thermal shock resistance, insulation, high CTI, EMI shielding, and one of the important one is also the flame retardancy, and this is what we will discuss today. Here in the first part we discussed insulation and isolation. I will link the video to the first part also, but for today we will discuss the flame retardancy. Okay, flammability and flame retardancy. So a general definition is, you can say it's the response of a material, can be plastic, can be wood, to thermal and electrical sources of combustion. So why is this important? Because not every material, and also within the thermoplastics, not every thermoplastic behave in the same way. On the one side, it depends on the intrinsic base polymer. For example, PPS is really hard to burn and has an intrinsic V0 level, and then it depends also on the additives you add, and also the combustion source itself, and therefore it is really important to have a good material understanding, how this material behaves to certain combustion risks. And here I have selected 3 important properties. So we have the underwriter laboratories, the UL flame ratings, we have the glow wire testing, and as a third the hot wire ignition and the high current arc ignition. So there, as already mentioned, there are different standards developed to estimate the flammability of plastics, and the most used is the UL94 flame ratings. And when I have a plastic compound, by adding additives I can improve certain things. For example, I can increase the ignition temperature, I can reduce the burn rate, I can use the flame spread, and I can reduce the smoke emission toxicity or density of the smoke itself. So for example, when you think of applications in railway, transportation, airplanes, there we want low smoke emission. And we have also self-extinguishing plastics, and this is measured with the limiting oxygen index, so the LOI. And here's a rule of thumb: when you have a LOI bigger than 21%, so with a safety factor of up to 28%, so when you take 28%, you have a self-extinguish material. Okay, let's start with the UL94 flammability ratings. So here in this table you see the different ratings you can have, starting from the easiest to the most difficult one, and also with some explanation. So we start with HB, which is horizontal burning, and continue then with vertical. So HB, V2, V1, V0, and then we have 5VB and 5VA. And here you see the different definitions and what is happening, and based on how the sample is burning, you can rate them. So here now explained the test setup. So the HB horizontal burning, you see here the specimen positioned in horizontal, and then here with the Bunsen burner start burning. Whereas with the vertical burning test for estimating V0, V1, V2, it is right above the Bunsen burner. And also to fulfill V0, we have the individual flame time under 10 seconds, then you have 5 specimens, so in total under 50 seconds, and glowing time, so below 30 seconds afterward. And there is also a cotton placed underneath, so when some particles drop on the cotton, it's not allowed to ignite the cotton. And here is then with V1 and V2. And it is also made with different millimeters of thickness, so you can test at 2 millimeter, 1 millimeter, 1.5 millimeter, or 0.4 millimeters. So you can rate the material according to the thickness of the sample. So vertical burning test is shown here. So we have a test plate, and the Bunsen burner is really hold underneath the plate. So before we just talk about, you can say sticks, but now we have really plates. And the key is to reach the 5VA level. It is not allowed to burn through the plate, so there is not allowed to have a hole then. Whereas in the 5VB this is allowed. So to summarize, HB, horizontal burn, is the lowest rating. Then we have vertical burn, so it burns short time, and followed by V0, for example, it burns a very short time and no flaming drips. And the 5VA is the highest rating, so no burning through. Then we continue with the glow wire testing. So there's the GWFI according to IEC 6695, and you can see here we have again our specimen, our plastic specimen, and a wire which is heated up and then touched on the specimen. And the aim is to measure the temperature which fulfills one of the conditions, for example, no ignition of the flake, and the burning time or glowing time is below 30 seconds after removal of the wire, and no ignition of the cotton underneath. And for example, when you have a specimen with 3 millimeter thickness at 850 degrees C, this would be then from the rating 850/3. And there are also other relevant standards, for example the IEC 6335, which is more used in the appliance and other industries. Then we have the glow wire ignition test. So it is similar. So we have again plastic specimen, the glow wire. However, it's not 30 seconds, it's only 5 seconds. And the indicated temperature is 25 degrees above the temperature where no ignition occurred. So this is the main difference. And here's the short summary between the two, the glow wire flammability index and the glow wire ignition temperature. So for the glow wire flammability, after burning time is below 30 seconds and test duration is 60 seconds, whereas the glow wire ignition, it's more stringent as the flame, as the extinguishing under 5 seconds. Okay, let's continue with the high current arc ignition, HAI. So we have here our specimen, can range between 0.4 to 3.2 millimeters. And then there is a wire winded around, so 5 turns. So it's a resistance wire. Then we put some electricity through the wire for a specific time, and as a result measure the time till ignition. So the longer the time, the better. And for example, the value 0 means it's the highest time, and what is meant on the highest time, it's 120 seconds or longer. So you can here see the table, so 120 seconds, it's then PLC class 0, and when it is just 7 seconds or below, it's the PLC class 5, so it's the worst. And then there is the hot wire ignition. So this time the specimen is here laying on a table, and we have the electrodes. So we have a fixed electrode and a movable electrode, and we induce 40 arcs per minute onto the sample. And now we measure the number of arc rupture explosives which are needed to ignite the plastic specimen. Here again 0 is the best rating, which is offered by the UL, so this is the underwriter's laboratory test, and which meant, so 0 means 120 arcs without burning. So you can see that here in the table 120 is 0, and when it is just 15 or below 15 we have 4. So there's in the other we have till 5, and in the hot wire ignition we have till 4. Okay, then there is the UL746C, which help us to choose compliant materials. And for example, we have here the hot wire ignition versus the high amperage ignition. And in the UL94 horizontal burn, that means we have PLC 2 and PLC 1. So this is then our field where we can choose. When we go to V2, we have still PLC 2 for HWI, however also PLC 2 for the HAI. And with V0 it's immediately extended to PLC 4 for HWI and for HI AI for till PLC 3. So based on the flame rating, it is increasing or decrease the material options. And with all this information learned now, we are able now to decode the yellow card, so the UL yellow card, which is used in electrics and electronics, and it's coming more and more also in the automotive e-mobility field. Here is an example, 33% glass fiber reinforced polyphthalamide, PPA, and in the first 2 boxes here you can see the flammability rating. We have different millimeters, 0.8, 1.5 and 3 millimeters, and you see here HB, that means the horizontal burn, and here the test methods UL94. Then we have some flammability classification also, and for the electrical properties here we have the hot wire ignition, so the HWI, and you see with 0.8 millimeter we have PLC 4, and at 3 millimeter we have PLC 0. So this has a impact depending the thickness of the part you have different, and the same is also valid for the high amp arc ignition. So however here it's from 0.8 to 3 millimeter, always PLC 0. And yeah, we have some further more properties here, like the CTI dielectric strength we discussed in the first part already, and volume resistivity also. Okay, if you want to have more information on polymer engineering topics, I highly recommend you my blog findoutaboutplastics.com, as well as my online courses on polymer material selection. I will link you both the blog and the courses in the description below. Okay, which video to watch next? Check out the first part of the series where we discuss electrical design properties for the polymer material selection for electric cars. I would like to thank you for watching, and do not forget to subscribe and smash that like button. Till next time, bye!